All right, let's get right into it. We're about to unpack the incredible 15 million year journey of human evolution. This is the story of how we went from ancient primates to, well, to us. You know, this whole epic tale really boils down to answering one single question. How did a small, hairy primate living in the forests millions of years ago eventually become the species that builds cities and flies to the moon? How did we go from that to this? Well, the answer, the main thread that connects every part of this story, is all about one single dramatic biological change. Our brain more than tripled in size. Seriously, that massive expansion is the engine that drives everything else. So, where do we even begin? We've got to rewind the clock, way back, about 15 million years ago. That's when the first tiny split appeared in our ancient family tree. And this was long before that big brain growth spurt really kicked off. And right here, you can see that first little fork in the road. On one side, you have Dryopithecus, pretty standard ape-like ancestor, walked on all fours. But on the other side, there's Ramapithecus, still hairy, still on four legs, but you start to see these tiny little hints, like a shorter jaw, that suggest the very first tentative steps towards standing up. This is the path that would eventually lead to us. Now, this is where things get really interesting. See, as the climate changed and the forests in Africa shrank into open grasslands, a totally new kind of evolutionary pressure started to build. And the first huge revolution wasn't about our brains, it was about our feet.
All that pressure gave rise to the Australopithecines. These are our famous ancestors who roamed the grasslands of East Africa somewhere between 2 and 4 million years ago. They are a major milestone on our journey.
And their big innovation, their game-changing adaptation, was bipedalism. And I don't just mean standing up once in a while. No, this was walking on 2 feet as their main way of getting around. It was a complete redesign of the body plan. But you know, evolution is never a free lunch, right? There are always trade-offs. Walking upright had huge advantages. Suddenly your hands are free to carry food, tools, or babies. You can see predators over the tall grass. But it also came with some serious costs, like all that strain on our backs and knees. Sound familiar?
And how do we know this for sure? Well, say hello to Lucy. This 3.2 million-year-old fossil was the smoking gun. Her skeleton, from her pelvis to her knees, just screamed bipedalism. She proved, without a doubt, that our ancestors were walking upright millions of years before their brains started to get big. And the proof is right there in the skull. The brain of an Australopithecus was still pretty small, only about 500 cubic centimeters. So the evidence is crystal clear. The body changed first. The big brains would have to wait their turn.
Okay, so our hands are free. Now what? Well, the whole evolutionary game changes. The pressure isn't just about moving around efficiently anymore. Now it's about what you can do with those newly freed hands. The focus shifts to innovation.
And that brings us to Homo habilis, who shows up on the scene around 2 million years ago. This is a huge deal because this is the first species we put in our own genus, Homo. This is the first of our ancestors that we really consider human-like.
Their name literally means handyman. And that tells you everything you need to know. The critical leap forward, the thing that defines them, was being the first to intentionally, purposefully, make stone tools.
And listen, we're not just talking about smashing rocks together. The Oldowan tool tradition required some serious brain power. You had to have a plan, you needed fine motor control, you had to see the tool hiding inside the rock before you made it. That is a massive cognitive leap, and you see it reflected in their brain, which grew to between 650 and 800 cubic centimeters.
All right, next up we have Homo erectus. They evolved from habilis, and they're the ones who really perfected that fully upright stance. They were basically built for long-distance running and walking, which is probably why they were the very first hominid to migrate out of Africa and spread across the world. But their most important breakthrough, the one innovation that changed absolutely everything for us, was mastering fire. This one piece of technology would literally rewire our biology from the inside out. So think about it like an energy budget. A big gut to digest raw food costs a ton of energy. A big brain also costs a ton of energy. It's really hard to afford both. But when we started cooking our food, we were basically digesting it outside our bodies. This let our guts shrink, which saved a massive amount of energy. And where did all that extra energy go? It got redirected to the other super expensive organ, the brain. Fire literally paid the metabolic bill for our intelligence.
So now you've got this incredible engine running. Better tools get you better food. Fire makes that food easier to digest. That fuels a bigger brain, which can then invent even better tools. It's this amazing positive feedback loop that acted like an evolutionary supercharger, and it kicked off an era of hominids with truly giant brains.
Now, at this point in history, there were two incredible groups living at the same time. You have our famous evolutionary cousins, the Neanderthals, who were incredibly successful in Ice Age Europe. And then you have our direct ancestors, the Cro-Magnon. And this is a really important point. Neanderthals were a separate, parallel branch, not our direct ancestors.
And what's so amazing is that both of these groups showed these undeniable signs of a complex modern mind. Neanderthals were burying their dead with tools and flowers, which suggests symbolic thought, maybe even some kind of belief in an afterlife. And Cro-Magnon, well, they were creating breathtaking cave art, which is clear evidence of abstract thought and the ability to tell stories.
So if both groups were so advanced, why did the Cro-Magnon line continue and the Neanderthals disappear? Well, the answer seems to lie on a final, crucial transition, from an evolution of the body to an evolution of culture. And this leads us to a really surprising twist in the tale. You'd think the story is just our brains getting bigger and bigger and bigger, right? Well, not exactly. Our brain size actually peaked with Cro-Magnon at a massive 1650 cubic centimeters. The average brain of a modern human is actually smaller, around 1350 cc. And what that suggests is pretty profound. It means our biological hardware, the modern human body and brain, was fully in place tens of thousands of years ago. It took a long time after that for our cultural software, things like agriculture, writing, and eventually civilization, to really get installed and take off. And that leaves us with a fascinating final thought. The fact that our brains are a bit smaller than our ancestors suggests that evolution's focus has shifted. Once our collective culture, our language, our technology, our shared knowledge could store information for us, the pressure for a bigger and bigger individual brain might have relaxed. It became less about sheer volume and more about the efficiency of the wiring and our ability to connect to that larger cultural